Okay, welcome to the DMZ configuration for the PIX firewall. In a DMZ configuration, what you have is an internal network and the outside network as before, but we're adding a third interface to the PIX, E2, which is the DMZ, and that's where we'll host our things like web servers, DNS servers, yeah, just different types of services and things like that that'll go on the DMZ. Things that we would want to allow the outside world to have access to, but things that but not quite things we would want them to have complete access to. Our internal network, we're never really going to want to expose to the outside world from the standpoint of allowing outside access in. But we would allow certain things from the outside in, like for instance, Central Piedmont would allow our Moodle server to effectively operate in the DMZ, at least logically operate that way. So the PIX firewall is going to have three interfaces in this arrangement. We're going to have the inside interface, the outside interface, and in this case, we're going to have the DMZ interface. Now, there's two ways through the PIX firewall from the inside out perspective. So this student PC here, if he wants to go to the web server out on the internet there, the web FTP, there's two ways of accomplishing that. That's either through a routed relationship or through a NAT relationship. And in our case, we're actually using a little bit of both. We're using a NAT relationship to map an inside address range to an outside address range, and we're also using a default route to route traffic to the external interface. In this arrangement here, we see that there's a first statement, NAT inside 1, 10.0.0.0, 255, 255.0. As we learned before, let's skip the second statement, go down to global outside 1. That will map the 10.0 addresses to a 192 here, the 192.168 0.20 to 0.254 range there in the global statement. So that's just a straight NAT relationship. Some other things we've got to keep in mind, though, when we're doing the DMZ configuration, for the internal clients to reach the web or FTP server on the DMZ, our internal clients also need a NAT relationship into the DMZ. So we see that our last statement there, global DMZ 1, 172.16.0.20 to 172.16.0.254, what that's going to do is map inside NAT requests from 10.0.0 to the IP address range 172.16.0.20 to 0.254 when clients are trying to go from the inside network to the DMZ. So just like going to the outside world, internal clients are going to get a NATed relationship to DMZ services in the DMZ. So in other words, if a student PC is trying to reach the web server, the PIX is going to establish a NATing relationship and forward that traffic out with a network address translation to the Bastion host or web server there. So as far as that Bastion host or web server is concerned, the traffic's coming from somewhere in its own subnet. So that's just something a little different to think of in the way it works. Now, there's another statement here, if you notice, in the second line we skipped, and that was NAT DMZ1 172.16.0.0 255 255.0. What that does is from when the Bastion host there in the DMZ or the web server, FTP server, whatever you like to call it, when it's trying to reach the internet, maybe to do an update or whatever, it also uses a NAT relationship to the normal global statement, global outside statement. So if the Bastion host there at 172.16.0.2 was trying to reach the internet to update some, let's say it's doing some type of update to a service it's running on the internet, uh, is when it connected to that website out on the internet, that website out on the internet would assume the traffic is coming from a 192.168.0.20 or somewhere between that and 0.254 due to the NAT relationship of the global outside command there in global outside 1. So in this case, instead of just matching a NAT inside to global outside command, we also have to have a NAT inside to global outside, and we also have to have a global DMZ command so that internal clients can reach the DMZ. We also have to have a NAT DMZ to match to the global outside command so that the web services or whatever on the DMZ can reach internet services. So basically we're adding 2 commands to our normal basic 6 here, and that would be the second command, NAT DMZ, and the last command there, global DMZ. And that's really the only difference. Now, not only do we have to establish differences in the natting relationship on the dynamic side, we also have to establish natting relationship on the static side like we did last time in inbound access, and we have to configure those access lists like we did last time in inbound access. So let's look at a few of the statements here on the right. The first few are pretty common to the PICs. We get that, the naming the interfaces. And again, remember, our named interfaces in NetLab and Sec 160 are a little different than the normal default for the PICs, and that's just the way the thing's wired. And the IP address statements are pretty common. The first thing of any note is we go down to the static statement. Now, last time in the inbound access list statements, it was static inside outside. Now it's static DMZ outside because we're going to map from the DMZ interface to the outside address or to the outside interface, and we're going to map in this statement here. If you look 192.168.0.11. That'll be the outside address, and to the internal address in the DMZ would be actually 172.16.0.2 in this case. So we're going to establish a static mapping just like we did before, but this time we're going to go from the DMZ to outside. Now in the next statement, the access list statement, we're going to call the access list ACLN DMZ. That's the name of the access list, and we're going to permit TCP from any host. From any source to host 192.168.0.11 when the traffic equals www, when it equals web traffic, or we could have said equal 80, but www and 80 will be the same thing in this case. So if the traffic is TCP and it's from port 80, we're going to allow that traffic to our 192.168.0.11 address. And remember, that's mapped statically, as you can see above, to 172.16.0.2 over in the DMZ. Now, the next statement of the DMZ is ACLN DMZ deny IP any. So we're not going to allow any other traffic. We're just going to allow that web traffic. And then that third statement, access-group ACLN DMZ, we're going to apply that in an inward direction to the outside interface. And that's just simply applying the access list. And the directionality is, of course, from the perspective if you were sitting in the center of the PICs. That would be the perspective you would, the in and out perspective. All right, let's take a look at a full configuration here before we jump into the lab. Let's look at statement by statement. PICs firewall config, name if, Ethernet 0, outside, security 0. Now again, in our case, for our lab, Ethernet 0 is going to be the inside interface. Doesn't really matter as long as we're consistent within our own conventions. But in this particular example, Ethernet 0 is going to be the outside, and the outside interface is going to be security level 0. It's the least trusted. The second line is name if Ethernet 1 inside, and inside is going to be the most trusted. We're going to give that a security level of 100. And this is new, or a little new. The third interface is Ethernet 2, and that's DMZ, we're going to call it, and we're going to give it a security level of 50. Notice it's kind of in the middle in terms of trusted. So again, for us to have a NAT relationship, remember we have to come from a higher security level to a lower. So we can have a NAT relationship between inside and outside because 100 is greater than 0. We can have a NAT relationship between inside and DMZ because 100 is greater than 50. And we can also have a NAT relationship between DMZ and outside because 50 is greater than 0. And now, in this case, we would not have a NAT relationship between outside and either of the other interfaces, nor would we have a NAT relationship from traffic initiated from DMZ to the inside. DMZ could not initiate traffic and go to the inside without an access list. And traffic could not come from the outside world into the DMZ without an access list. IP address outside 192.168.0.2, 255.255.255.0. That sets the IP address of the outside interface. And again, the next two statements, IP address inside, IP address DMZ, do simply the same thing and set the IP address. Looking at the next statements, NAT inside 1, that establishes a NAT relationship between the inside interface and the global outside 1 next statement to that NAT pool. And again, also remember that if I were just to use a single address in the global statement, that would be port overload and instead of just NAT. The next statement maps the global statement to the DMZ, which what that's going to allow us to do is our inside clients are going to be natted when they're talking to the server out on the DMZ. We did not do a NAT statement in this case for the systems out on the DMZ to talk to the internet because there's only one system and we just established a static relationship in this case. We could put both in there, but they're just going to go with a single static in this example. Static DMZ to the outside. The outside address will be 192.168.0.11. The inside address will be 172.16.0.2 in this case. The last few statements there, access list ACL DMZ is going to permit TCP traffic from any source to the host 192.168.0.11 as long as it is equal to port 80 or www traffic. The next statement, an access list, denies everything else, and the last statement applies it in an interface in condition to the outside interface. And that's basically the configuration of the three-legged DMZ for the PIX firewall. And we'll now do a lab to demonstrate that.